Hi, I'm the Math Guy Steve. Let's try evaluating this integral. So when evaluating integrals like this, so it only has one term in there. There's no special tools that we have to try to evaluate these other than to try, if nothing else works, just try using by parts. Okay, so you would think, okay, well, how would I use by parts here? Remember, by parts says, okay, if I can write this as the integral of u dv, then that equals uv minus the integral of v du. This is our by parts formula. Okay, so the way to remember uv minus the integral of v du, think ultraviolet voodoo. Okay, we're from New Orleans here. So ultraviolet voodoo is one way to think about it. Okay, uv minus the integral of v du. So let's try to write it in this form, meaning I need to write this as the integral of u dv. So let u be the ln of x, okay? Then the dv will just be the rest of it. So in this case, the dv would be just dx, all right? And now we derive down, integrate up, okay? Derive down, integrate up, meaning if I take the derivative, okay, derive down, then the derivative of u would be du. Derivative of ln of x is 1 over x dx, okay? And then integrate up, we integrate up, okay, integrate up. So the integral of dv is just v, and the integral of dx is just x, okay? So this becomes my sub-bubble here, okay? Derive down, integrate up. All right, okay. And now it's in this form, and now we can rewrite this integral as uv minus the integral of v du, ultraviolet voodoo. Let's try it. All right, so our u here was that ln of x, okay? So we're gonna write ln of x, okay? V ended up being just x, okay, just x, minus the integral of v, that same x. And recall that du was 1 over x dx. So we get times 1 over x dx. And now hopefully that voodoo part is a lot easier to deal with, okay? Voodoo is not that easy to deal with in where I'm from. Anyway, okay, so this gives us what? Okay, that's ln of x times x. So x ln of x, minus the integral of. But then the x and 1 over x cancel. So we just end up with just integral of dx. Now the integral of dx is pretty easy. Okay, that's just x. So we end up with x ln of x minus x, okay? Now, once we're done integrating, don't forget that plus c at the end, all right? So if the indefinite integral plus some constants, that is a constant with respect to the variable x, okay? We can always check this. That's a Nike step, the check step, by just taking the derivative of this and making sure we get back to that integrand, the thing we were integrating, okay? All right. Always remember, math is everywhere.